2.3, we're using implicit differentiation, which means that we're not necessarily solving for y at the beginning. Instead, we're finding the derivative of y in the middle of a problem and then solving for y prime. A lot of times you can't solve for y, and we need to use implicit differentiation. So let's look at what's going on in E of number 1. Here we've got a function where it would literally be impossible to solve for y because we have a y squared and a y. Instead, we can just take the derivative of the function we see here, and what we do is we just do d dx, the derivative with respect to x, on both sides, and when we do the derivative with respect to x on the left side, we get 3x squared plus, this is a product rule, we do the derivative of the first times the second plus, leave the first one alone, times the derivative of the second, the derivative of y. I'm going to put y prime. We could also put dy dx, and that would be fine too. Plus the derivative of this guy. We have a chain rule. This isn't 4x squared. This is 4 something squared. The derivative of 4 times something squared, we can do the power rule. It's going to be 8 times that something, but then times the derivative of the inside function. Here y was our inside function, and we have to do the chain rule on it, equals the derivative on the right side is 0. I will tell you, this is like the number one mistake I see kids make, is that they forget to take the derivative of the right side. What we're going to do next is we're going to isolate y prime. We're going to get all the y primes on the left side and all the non-y primes on the right side. So I'm going to subtract 3x squared and 2xy on both sides. And I'm also at the same time going to factor out, since we have nothing but y primes left on this side, I'm going to factor out the y prime. So we get y prime times what's left over from here is x squared plus 8y. And again, on the other side, we've got negative 3x squared minus 2xy. The last step to solve for y prime is, since y prime is being multiplied by something, we divide by it. Y prime is going to equal negative 3x squared minus 2xy, what the right side was equal to, divided by x squared plus 8y. This can't be simplified. This is y prime. Alright, number 3, equation of the tangent line. I'm not going to do this problem for you, but this is something you've got to be automatic at this point on. The equation of the tangent line is going to be y equals m times x minus x1 plus y1, where x1, y1 is a point, so you need a point, which we have. They actually already gave it to us, and we need m. This is going to be y prime evaluated at, y prime, not y1. Y prime evaluated at the x value, which in this case is 1. So we're going to find the derivative using implicit differentiation, plug in the x value, and maybe the y value as well. So we're going to evaluate the derivative, and that'll be our slope for our tangent line. Alright, I'm going to do one of these guys. Here, we're going to do finding the second derivative. So let's look at how this works. To find the second derivative, you have to first find the first derivative. First derivative is 18x plus 2y times y prime. We're doing the derivative on both sides, equals 0. It's much easier to do this one using implicit differentiation than it is to do it using explicit differentiation. Now, if I were solving for y prime, I would move the 18x and divide by 2y, but I'm not. Instead, I'm solving for y prime, and so I'm going to continue, well, let's solve for y prime. Y prime is negative 18x divided by 2y, which is negative 9x over y. I subtracted the 18x and divided by 2y. Okay, so I could do this either using explicit or implicit differentiation, and since I already have y prime solved for, I think I'm just going to go ahead and take the derivative. So the second derivative is going to equal, this is a quotient, so I need to do the quotient rule, the derivative of the top times the bottom, minus, leave the top alone, times the derivative of the bottom. The derivative of 2y is times 2y prime, all over the bottom. Why am I doing this? Oh my goodness, guys, let's use the simplified version. Let's just start over. It's going to save us some time. Even though we had already started it, it's better to use the simplified version because it'll be much easier. So, still, same deal. Quotient rule. Derivative of the top times the bottom minus, leave the top alone, times the derivative of the bottom, which is y prime, all over the bottom squared. So y prime prime equals negative 9y plus 9xy prime all over y squared. Now it's said to find it in terms of x and y. That means I can't leave this y prime here. So I now need to substitute in what y prime is equal to get it in terms of x and y. 9x times negative 9x over y all over y squared. Notice all I'm doing here, so you guys can't see that, all I'm doing here is I took the y prime and replaced it with what y prime is equal to. Here we had y prime equal negative 9x over y, so we put it, and now this is in terms of x and y. And I could simplify it, but I'm not going to in this homework. You should. On the back, I don't see anything crazy. I'll just pick one that I think we should do together. Let's do number 6. It asks us to find y prime. And so we're going to do explicit or implicit differentiation. I'm going to actually solve this two ways for you. The first way is to do an implicit differentiation where we do the derivative of the top. This is a quotient rule, so it's the derivative of the top, which is cosine of y, times the derivative of the inside, which is y prime, derivative of the top times the bottom, minus the derivative of the bottom, which is negative sine of x, times the top left alone, all over the bottom squared, equals, over here we get 4, just 4. The derivative of 4x is just 4. And we can solve to get y prime by itself. To get y prime by itself, we've got to get rid of all this other junk. I'm going to start by simplifying minus a negative is a positive. And then we need to multiply out the denominator. So it's dividing by cosine squared. We're going to multiply by cosine squared. I'm not going to rewrite it. I'm just going to say this is what we've got. So we want to get the y prime by itself, so we want to move this to the other side. Notice that these cannot be combined because one is sine of x, one is sine of y. So this is being added, so we need to subtract it. So we're going to do minus sine of x, sine of y. And lastly, we need to divide by everything that isn't y prime. So y prime is going to equal all of the things we had on the other side, 4 cosine squared of x minus sine of x, sine of y, all over, when we divide, we're dividing by cosine of x, cosine of y. I rearranged these just because we usually put x's before y's, so I divided by cosine of x and divided by cosine of y, and that got the y prime by itself. That's what y prime is equal to. So hopefully that's helpful. There's another thing we could have done here if we'd wanted, which is to make it a little bit easier to get y prime up by itself. One thing we can do is avoid using the quotient rule by isolating the sine of y. We can't get y by itself, but what we can do is get sine of y equals 4x cosine of x. This is just another way to do this problem. You always want to be out on the lookout for easy ways to do things. And now we don't need to use the quotient rule, we can just use the product rule on the other side. The derivative of sine of y is cosine of y times y prime. Over here we need to use the product rule, because we have two things multiplying. The derivative of the first times the second, plus, leave the first alone, times the derivative of the second. And now we see this is much easier. I'm going to simplify this here. This is minus 4x sine of x all over cosine of y. Now you might be asking yourself, this looks a lot simpler, and the method was simpler, but even the answer at the end looks simpler. These don't look the same. And the question is, how could they be the same? Well, you'll notice that this one has a sine of y in it, and this one doesn't. If at the very beginning you go back and solve for sine of y, get sine of y is equal to 4x cosine of x, and plug that in to the other equation where there's a sine of y, what you'll notice is there'll be cosine of x in all the different terms, and you can divide by cosine of x, and it ends up equaling the same thing. So, different way of doing it, but also works. Kind of crazy stuff. Hope this helps on your homework. Good luck on the rest of it.